Need to make sure we start recording this. All right. Now, what I want to share with you is this document, which it already appears on your, okay, where did it go? It appears on the documents that you have from your, uh, God, I'm drawing a blank. What is my document? When you open the document for the e-commerce project, I'm asking you to select from companies that work with metadata, demographics, gathering competitive intelligence, hosting services, global statistics and resources, or job databases. Companies work within these 6 items. So when you pick a company, I'm asking you, okay, where does your company fall into this, in any of these groups? Is your company making a living, gaining profit, making profit out of selling, buying, storing, or working with demographics? Does your company work with the global statistics and resources? Does your company does hosting services? And I'm asking you this because if you tell me I just picked this company and this company can encompass all these items, gathering comparative intelligence, demographics, and statistics and resources. So I'm asking you, is that how your company makes a living? Is how your company is making profit? Or is those are items that are peripheral to the company? Most retail companies will make money by selling, by buying, or by working with a specific set of goods. If it's not actual goods, it's services. That's what I'm asking you to identify this. You don't know what metadata is because you haven't worked with metadata yet. Maybe you do because you work in the background with computer applications and you're involved in this kind of situation. But if you do not know, you will have to go back and say, what is metadata? With data about data. That's what metadata is. So if your company works on metadata, it's because they're making money with data. What is the biggest metadata company in the world? Any company that sells music. Because when you sell music, like iTunes, like Amazon Music, like Spotify, you store information based on a set of parameters, which is the music, but you have different options within that music to identify that specific set of music. All those parameters that identify music is are built into a simple set of databases that are called metadata. Well, they're not simple. They're rather extensive and allows you to search information. That's why you can put a search for a certain amount of lyrics or a title, and you can actually find a song because the metadata is allowing you to look for that kind of information. Demographics. Who makes money buying and selling demographic information? I give you the US Census Bureau. Well, the US Census Bureau, you say it doesn't make money because it's a part of the federal government. Well, actually, yes and no. Yes, it is part of the federal government, but it's certain data that if you want from the US Census Bureau, you have to buy it. They sell it to you, especially if you're a company trying to collect a large amount of information. So that's one option that you have. Gathering competitive intelligence. What do you do when you gather competitive intelligence? Can you say Amazon? Can you say Google? Companies that are worldwide that are always looking at what everybody else does. Can you say Walmart? Can you say dealers? Can you say any retail company that is looking to enhance their competitive edge and make a profit? That return on investment on anything that they buy, they purchase, they acquire, they lend is looking to gather a better position for them to be above the competition. So you're gathering competitive intelligence. Hosting services. Are you a website? Are you an IP service provider? Do you sell email? Are you hosting somebody's name? Are you selling the access to the internet with your company? That's the kind of stuff that you're talking about when you're talking about a hosting service. Okay, let me see. Global statistics resources. Business model dependent on collection and vending of global statistics. Can you talk about Moody's Analytics? IBM Analytics. IBM is a very large company. They not only make computers, they make software, they make hardware. Well, one of the software applications they sell and one of the business applications they sell is analytics. You want to rate your company in the market? You can look at Moody's Analytics. They will tell you where your company is because they look at the type of business that you have, your debt, your collections, your balance sheets, and they tell you, is your profitability good enough to rank anywhere? Many companies are able to sell and buy themselves when they go rated by Moody's. Many companies will not buy unless they find a rating in Moody's. Well, it's a type of a global statistics and resource. Job databases. Can you say Monster? Can you say Indeed? Anybody that is selling jobs by posting resumes, so on and so forth. That's the kind of stuff you're looking at. So, in short, when you pick a company that I hope you have for me today, some of you already gave me your companies, ask yourself these questions and figure out this because when you make your presentation, when you make your rough draft by the fourth week of class, you are going to tell me I choose XY company because they are making a living of a metadata or gathering competitive intelligence or so on and so forth. I'm not going to tell you you cannot participate on something because somebody already picked the company. I am actually very interested to see what is it that two or three of you come up with the same company and actually do a presentation and and see what was your approach to that presentation. In any case, make a decision on the company, do a quick analysis of where is your company regarding these 5, 6 topics that we have in here. Give me that information today. Because remember, in 4 weeks or 2 more weeks from now, you're going to give me a rough draft of what is happening for you. So it's important that we do that. All right. Any questions before we move on?
Real fast.
I beg your pardon?
How do you want the company? Should we just email it to you or?
Yes. Just email me directly and say, I want to pick this company.
Okay, thank you.
And give me a reason why you're picking that company. Give me the identifier that you pick. Which one of the 6 items is the best for you that meets your description? What I'm trying to figure out from you is, are you understanding the concept of what we're trying to do when you pick a company? Okay, great. Good question, Sergio. Anybody else? All right, already got 2 in here. Good. You guys are busy already. Good. All right, let's move on. Okay, homework number 2. we already discussed it. That's going to be your a form, a macro Google form. It's already posted on your Canvas page, module number 2. So you can start responding to that. It's due on Sunday by midnight. If you still have not provided me with homework number 1, the survey, please do so. I still want to know about it. I still want to continue collecting that information. We will work. If you're having difficulties of any kind, let me know so we can work them out. I'm willing to listen. We're willing to work things out. Don't stop communicating. Discussion number 2. Discussion number 2 opens today too at 6. As I stated earlier, I am extremely pleased with your discussion number 1. Everybody really engaged the conversations. The sooner you're able to post your response to the conversation, the sooner you're going to engage more and more of your peers. It's very important that we do that. If you wait till the end, I know everybody's busy, but if you wait till the end, you're missing the conversation that is ensuing on everybody. Again, thank you for maintaining that professionalism and your decorum in the conversation. It's very nice to see that. All right, the projects, we discussed this. Please give them to me today. You continue to come up with information, which is great. Now, we have today software applications, types of software, and the first item that comes to our plate is operating systems. So the operating systems is how are we connecting, how are we allowing the system to talk to us? How is that system, computer application saying, how can we talk to somebody within the computer or within the cloud or anything that we're working with? So basically the operating system manage the hardware on this, manage the hardware on the computer and interfaces with the software application. Because remember, all software is instructions. When you write software, all you're doing is writing instructions for a piece of hardware, a piece of solid piece of chip or something that is interfacing with the machine to do something for you and perform a specific task. We have a graph in here that describe basically software. You have the user, that's you, and you have the operating system, and you have the application, which is the other type of software. Well, in between the software and the hardware, you have the operating system. You are the requester. You're using applications, which is the other type of software, through the operating system to make sure the hardware does what you want to do and come up with the information. When we're talking about software, we're talking about application software, we're talking about productivity software, utility software, and program software. Applications for the enterprise, the companies. Enterprise resource planning applications. Now we're getting into very specific type of softwares. Now we're getting into software applications that directly impact the management and the operation of the company. Customer relationship management, supply chain management software. These are software applications that are going to impact everything that we do with the company. Your productivity software, everybody or most of us use Microsoft Office today. If you use, some of you may use an open source software. Somebody that uses software that is not necessarily tied to a company like Microsoft. Open source is written for anybody to use and modify. But in today's environment, a lot of people write open software mimicking actual software from Microsoft. Why they do that? Because they figured it's a lot easier to maintain something that is similar to what everybody knows, at the same time providing you software that you can use cheap because it's free, good because if you want to manipulate it, you can manipulate it, improve it, and you can do so. So when you do all these, you have applications that allows you to work for productivity for yourselves, whether you use it at home or whether you use it at the office. It's a utility type of package. Then you have applications that are going to be used for the enterprise. These are actual pieces of software that are written for within the application itself, not necessarily related to the uh, the software itself, not necessarily to the hardware, but it's software that is going to be used directly to work with the actual enterprise application that we have. For example, a payroll system. A payroll system is something that is within the company and everybody uses, and then everybody will put to work for yourselves, especially the finance department. So when you buy a payroll system, you can buy it either as a standalone program or you buy a big application, a big umbrella application that installs and everybody in the company will use with a specific sets of details allowed to them. So the people in finance use the accounting system. The people in HR use the human resources part. The people in a specific shop will use part of the human resources, part of the accounting, part of the actual shipping and receiving, for example. So basically, that productivity software that we're talking about is installed on top of everything and it interfaces with your productivity application. Your enterprise planning, resource planning software is designed to bring everything that we have together within the within the company. It uses a centralized database and it allows everybody to connect. Different companies operate differently. They have different applications because it's usually geared to the type of industry that you're working for. You have applications still for example, in the school district, we have an application type that enable us to see information for the people in the back office and people in the front office. We have applications that are exclusively designed for the students use and applications that is strictly designed for the campus use. In your company, you may have the same type of application or alike, but it would only work for transportation, for HR, for accounting, inventory management, purchase management, supply. So when we're talking about these enterprise resource planning applications, it involves all these different items. So think about it. We have an umbrella comes on top of everything, and different sections of the company work with everything. Different people of the company will have access to everything in here, although it's not recommended, and we'll see later on in the course that this is not something that you do where one person will have access to everything. Even the president of the company that wants to have access to everything usually doesn't have all the access because he doesn't use most of the stuff. He may not need it, so it's something to work with. So it's implemented in organization wide. Everybody has it. Utilizes a central database. It's a software application used by many in the organization. Every department will touch it. Every department will have access to it. The customer relationship management program or CRM is basically a program that enables you to manage your customers. So people will say, well, this is good for sales, right? Well, yeah, it's primarily created for sales, but anybody that has to maintain relationships with customers will use something like this. Why? Because what it does is enables you to manage that volume of information that is created by managing customers. You have personal information, business information, address information, purchasing information, accounting information. It's not as detailed as what you saw here with the ERP system, but resides as part as how you're managing those customers. In many cases, an application like this will be tied to your enterprise system. Why? Because you don't want to reproduce everything in here when you already have it existing in here with the enterprise resource system. So the customer relationship management is just to help you manage information. In here, I'm giving you an example of what industry considers the top items in the market today. This is not something that we buy ourselves for our personal use on a normal basis. This is something that resides on companies. That way they can help them manage. Even a small business, you and your partner or partners and 20 employees, usually you will not have something like this because it's too big for a small company. But if you have 2,500 employees and you're listed on 5 different cities or 4 different cities or one city, you will need something like this to help you manage information on top of what you have with your ERP system. Your supply chain management is now is a system that is going to enable us to interconnect all the phases of the logistics process. So if you think about it, you have an enterprise management system and you're looking now at supply chain management system. And they can coexist because you have inventory management in here, you have manufacturing in here, you have supply chain management in here. But this supply chain management is when you are expanding fast, when your detail of inventory requires you to go beyond what the regular enterprise management system will provide you to work with. So it's important to see these because this is the kind of item that you have in a company like Walmart, in a company like Target, in a company like Amazon, where they depend so much on transportation, distribution, procurement, storage, design of everything. How are you going to work with this? Whether it's integrated, it's internal, or it's a whole item that applies to you in the company. So a supply chain management or an integrated supply chain management system that exists in a smaller format within the company. This is more or less what you have. This integrated supply chain management is what you have when you come in here and work with the ERP system. This item is something much larger that you're going to have in there. When you're talking about a plain supply chain management system, same format that you have in here, you're looking at basically this customer and suppliers and what happens in between both of you, the internal supply chain of the company, purchasing, distribution, and production. All three are happening from the supplier to the customer. You notice in here, it doesn't say about warehousing. It doesn't say specifics about procurement. It doesn't say anything about anything. It just very much simplified this large picture in here. So supply chain management, this is something that you're gonna see when you're talking about your companies. How is your supply chain management? In many cases, you're gonna be able to find out exactly who it is and what they do and how they do it. Walmart is very proud of their system. Amazon is very proud of their system and everything they do. And they have set them up in a way that is exclusively an item that they own and manage and they handle. Okay. One of the things that when we're talking about software today, we're talking about mobile applications. This is something that is new per se. The advent of the tablet, the advent, am I recording this? I think I was, guys.
Yes, you are.
I'm recording, yes. Important, so we can have it at the end. So the mobile application is basically a new item. As I was saying before, the advent of the smartphone, the tablet, the mobile computing has created applications that are called they're considered mobile applications. A mobile application is basically software, but what is different is that the developer has able to figure out a way that when you see the same website in your phone or in your tablet versus your 26-inch screen or 17 or 14-inch screen, it shows in a relevant and good format. You notice when you look at your mobile phone, when you look at the app in this phone, it's good. You can see clearly what you want. But when the app has not been developed to be used on the phone or configured for iPhones or for Android phones, it looks quirky. The titles overlap. The fonts are incorrect. The graphics doesn't display correctly. That is because the developer has not created what is called an actual mobile app. Well, the mobile app in turn created something else. Now we have a whole genre of items that are purchased, acquired, or downloaded through the mobile app store. Before we just Google for something and we go back and get it. Now we can actually go to through our phones, our tablets, our laptops, our computers, through our mobile, through an app store and download the mobile application or actual application that we intend to use. And you have noticed this when you access an app on your phone through the browser of the phone. And the browser tells you this will be better if you download the mobile app. Why? Because the browser is recognizing that you're trying to view something that is better related through the mobile application than through the actual uh, browser itself. A point in case, a very common issue is Facebook. If you use Facebook on your phone without using the app or on a tablet without using the actual app, the format of the screen is very cumbersome versus if you download the actual application to view on the mobile app from your phone or from your tablet. That's one example. All the different social apps out there are basically created the same way. Actually, something like Instagram, Twitter, uh, any of these other apps have been designed, yes, has all these applications have been designed so they work better for you on the mobile phone and not on the uh, actual software on a big screen. Why? Because developers have seen that it's easier for them to produce it on the mobile phone. That's the intent versus the actual uh, desktop application in large. What they have done is they figure how many people are actually accessing an app versus a website, because you can actually tell when you see your actual breakdown, and you can actually see that you have many more app users than you do website users. So they redevelop the application so it will come out through a mobile application. So in essence, mobile application has become something that is new on a market. Something else new is cloud computing. We used to, even as of a year ago, a year and a half ago, people used to wonder, cloud computing, my sending to the clouds. I'm looking up, looking at the clouds. Where is everything? Where is my data? I'm sending everything out there. Well, all we're doing is using the internet to move everything onto a location that is a virtual location and store our information in there. Big examples are Google Drive, Apple Cloud, OneDrive, so on and so forth. Many companies have produced ways for you to store information, whether it's proprietary of them or through a free service, which like Google that gives you, or Apple Cloud or OneDrive, which they give you a set amount of information. And after that, you can purchase more if you run out of space. It's cheap and you can do it. There are pros and cons, and a lot of people say, well, I really don't trust it. A lot of people say, I really trust it. I really want to stay with it. So it's up to the user per se. How do you want to keep it going in there? It's coming out to be a great tool to use because it enables us to work anywhere in the world that we are. As long as we have internet, we can actually move stuff into the cloud and access it. And anywhere we are, we can display the information in here. Canvas is a type of application that is an internet based, and we're using it in here for you to use it. As long as you have internet access to the university, you can access your Canvas page and view the information. You personally may have Apple Cloud, OneDrive, Google Drive, or any other storage format, and you can actually view information, store information, or work from there. Another type of format of softwares that we see today is virtualization. Virtualization is basically saying, I have software and I don't have an actual physical machine for that software. I have a virtual created image of what I have. It's very close to the Google Drive and the Apple Cloud and the OneDrive, with the difference that Google, Apple, OneDrive, all these storage formats is all they are, storage. When you're talking a virtual application, you actually log in into an operating format. If you ever access the University of the Incarnate Word virtual lab, which I encourage you to do if you haven't done it yet, you can actually log in and see what happens with, let's see if he lets me do it. Can anybody see the screen of the, this is how it starts to look. We're gonna log in, see if he let us in. course it doesn't let me in. But what I'm doing is actually logging into a machine at the university who is showing me, well, it's not gonna let me in. It's a machine that is allowing me to make sure I'm sharing you the correct information. It's allowing me to share, to access an actual operating system that works virtually. And you can see all the information that you were to work with. You see software applications, you see working places, you see actual operating system, but it's all set up in a virtual environment. If you were to save on it, you're actually saving on a machine that is not directly on your computer. The machine is actually at the university, wherever the university has this server set up for the machine to work with. So when you work in here, you're not actually working on your personal machine, you're working on somebody else's, the university. This is very extremely useful when you're working with software applications that you do not have because they're too expensive, too complicated to use, and you're required to use it. We use it a lot when we're working with the database classes or with the Excel classes, because if you don't have Microsoft Office, you can actually use this application to log in and have an actual access to a virtual network to use it. Nowadays, with Microsoft Office 2016, you can actually access it through the university without having to access the virtual network. But if we were to work with an application for statistics, SPSS, the system is already set up in here to work with it. So you could access that application without having to own one or having to download it, because it's extremely difficult to install, it's extremely expensive to buy. So the university provided for us. So we're accessing a virtual location, not a physical location, because it's not your computer. So you may, in essence, says you're accessing the server of the university, which is a physical location, to access another operating system, which is the operating system for the university, to show you that information. I encourage you to go to the virtual lab, because you're gonna see a lot of information in there that is very useful and very good to use. And if you have never used it, it's really good to work and see where you're at with it. When we have software, which is basically creating instructions, you are creating a program or a series of instructions that is done by an individual, several programmers, or we can actually go back to our discussion number one and actually have artificial intelligence that is actually enabling us to create instructions for software creation. Simple instructions that enable us to work with. So, as I say here, it's originally a process of one individual to create one entire program, or several programmers to create portions of the program. This is important to know, because when you get into software creation, if you ever want to get into something like that, also you understand why software is created. Software used to be created when you write a program and you write from the beginning to the end. You write code, all the instructions step by step on what to do. Or you get a bunch of people, and each person create a different section of the steps that we want, and then we put them together. The basic example is this. If I were to tell you to create a software application that details your waking up in the morning. What will you do? What are the instructions that you're going to give that software application? Every step that you take from the minute you open your eyes and in your mind you say, it's time to get up. Or when you are shocked by an alarm system telling you, wake up, and you reach out and slam that alarm system so it stops breaking you up. From that point on, you begin writing instruction by instruction until you leave the house and close that door. I guarantee you, when you start doing that, which is basically the same setup of instructions creating a program, you program have probably 50 lines of code. Now, any programmer will tell you, you start with the basic process. You get up, get dressed, eat breakfast, you depart. But what happened in between? Okay, so from get up to get dressed, what happened? From get dressed to eat breakfast, what happened? From get dressed, eating breakfast, from eating breakfast to leaving the house, what happened? All these steps you took to do that part of the software is the same equivalent of creating a piece of software, either by yourself or somebody in your family documents you from the minute you get up until you take a shower. Somebody else in your family documents from the minute you take a shower until you get dressed. Somebody else does get dressed to breakfast. Somebody else does breakfast leaving the house. Then we get all 5 pieces and we put them together going to work in the morning. That's the software you wrote. Basically, that's what you're doing in here. When you create software, you're doing this. When we create software, we write code and it's just instructions. The original setup of software was a very complicated one. It requires you to do very specific things. You have to know language, you have to know punctuation, you have to know all sorts of formats. It's getting more and more mainstream. This is an example of Java software, writing code in Java. For many of us, this is foreign language. It's a foreign language. On its own, yes. Once you begin studying, you start understanding the concept of what it means, what it's trying to do, what is going to happen. What has evolved is how is this coming about? Before, in order to go from step 1 through step 8 on this writing of software, we had to know every single item that we were going to write. On class 1, we talk about MS-DOS, the original operating system that we were working with. When you have that, you had to know every single step, every single command you have to do. The same thing in here. Now, what has happened is people figured out why cannot we help them out create this software by telling it, if you want to write about public class, these are the commands and these are the main comments that you use. When you want to write about print ln, these are all the differences that are available to use the command print ln. So when you're able to see graphically what we have in here, now what we have is a graphic user interface. So your software application has evolved. It's no longer something that is strictly code and you have to have memorized tons of words and tons of commands to write. Now you can write because you have a certainty that there is a command that enables you to see what you need to do and allows you to see different issues. When you start seeing small items like this, like that squiggly that is in red below the S in system, it's starting to tell you there is a problem with this word. It doesn't belong in there, or it doesn't recognize it, or the application itself cannot recognize where is it that you want to install it. So the software writing is becoming more and more intuitive for the developer. If you are the developer, it's going to happen to you. If you will be the developer, this is what is happening to you, or how it will happen to you. So that's creation in itself, yourself or a group of people. Now we have one item that is called open source software. When you have open source software, that means it's software that is free and available to you. You are free to use it. You are free to change it. The only caveat they have when they give you this software is that if you improve it, if you make changes to improve it, share it. Let people out there using it take advantage of what you just developed, what you just created. But if you don't develop anything, you just want to use it, you use it. And it's plain and simple. It works that way. So I'm going to link to this site. Let me see, make sure that you guys can see it. And this is just a website that has availability of software. And it gives you choices according to what you want to do and what you're looking for. They got items for everything, for games, for databases, for education, for systems, for terminals, anything for business or non-business, open source for anybody. Databases is one that I use a lot. So you can come back in here and see what is something that you will use for databases. If you're interested in databases and you cannot afford to buy something, you don't want to buy something, you just want to try and learn. Then you come back in here and you can start looking at it. You got reviews, you got how many downloads, when it happens, how it's happening, all these software applications that are available to you. If you're not into databases, you're into gaming and entertainment, then it gives you information in here of what to do by category, what you want to do it, how you want to do it. The only thing that you have to be aware when you work with something like this is that they may not function the same way you used to see them when you look at a plain Windows application. Because people is developing this, sometimes they don't use Windows, they use a different application. So it may be a little bit clunky or boxy or whatever, but that's the whole thing. It's free for you to use. You can download it and you can put it to work for yourself. Systems. When you're looking at systems, we talked in the beginning, what is the system application? What is that you're using in there? Well, you're using systems to communicate between the software and the hardware. The most common operating system that you're gonna find out there besides Windows is gonna be your Linux application. And Linux comes in different formats, different ways. There's so many of them. It's not even funny what you can do with them. But if you want to get into something that you may enjoy it, you can do it through here. The whole point in here is that you have an option to continue working with software. If you don't want to buy it, you can download something alike. You can do a plain search for free software, open software. Many cases, some of these people that you download for free, they're gonna charge you. They're not charging you for the software. They cannot charge you for the software. The developer says free. They may be charging you for packaging or for labels or for application that is the actual manual, so on and so forth. But in many cases, you're going to find out that you can download it for free and you print your own manual. Just go somewhere else. Don't pay for anything that is free. But I'm giving you this software location, SourceForge, because it's a good location for you to find if you want to get into free and open software for you to use. Databases, data and databases. As a disclaimer on this, I'm going to tell you databases alone will take a whole year worth of cows. So what we're going to touch in here in 1 hour of class, we're not going to even skim the top of it. So it's just informational in nature for you. It's important to understand it because you may use it, you may not use it, but basically all of us are involved with it. Basically, all of us are working with databases at one point or another. Now, when we're talking about databases, there's an item that we need to understand because not only databases, but spreadsheets, anything that involves working with actual information, is we need to understand the difference on data and datum. If you do a definition by a dictionary of data, quantities, characters, symbols from which operations are performed. That's what Oxford says. Webster says factual information used as a basis for reasoning, discussing, and or calculating. Makes a lot of sense. That's what data is all about. This is data. A bunch of ones and zeros, binary code. It means something to somebody. Datum, one piece of information that belongs to data. So understand this, data and datum, when you're addressing your information. One piece of information may contain a lot of facts of data, a lot of parts of data, or you may be talking about the one or the zero of the 011 set of information of data that you have available. It's important to understand this because when you're talking about data, as I said before in our previous class, when we're talking about data, we tend to interchange the singular, and the plural of data. But the singular of data is datum, one item. The multiple items of datum is data. So please understand that this is important. We're going to be working with it every time we work with a database. When you talk about forms of data, you have quantitative or qualitative. So what is quantitative? It's numeric information. Qualitative, descriptive information. Quantitative, I think I misspoke. Quantitative, numeric information. 2 times 2 equals 4. Qualitative, we're describing the information. My favorite number is 5. So we're addressing information itself in here the way we want to address it. Again, this becomes important because when you go back and start looking at data, you start looking at information and say, okay, how is that information supposed to help me out? Well, is big data, is little data? Is it something that I really need to have? Or is something that is really affecting me in any way? Well, when it's affecting you, it's because you have these items in here: data, information, knowledge, and wisdom. When you have data, information, knowledge, and wisdom, which basically flows either upward or downward, as we look at the definition, data enables us to be able to manipulate information or manipulate the sets of data, that datum, manipulate it to make data, which in turns, when it's coherent, becomes information. This is very important because data that doesn't have any coherence at all, nobody understands it, nobody knows what it is not data. It becomes garbage. But if it's actual information that is uh, understandable, that data becomes information. When that information can be acted on, can be made productive for us, it becomes knowledge. And the more knowledge we have wisdom now. And this information ladder, you apply it to everything, but it always remains starting with data. Okay, what is the database? All the database, in a true definition of databases are just a collection of tables organized to collect information. So my question to you is: Microsoft Excel a database? Anyone? Will you consider Microsoft Excel a database?
No,
Why?
it's not. Databases are usually large and massive amount of information. Excel doesn't have the capabilities to be considered a database.
Okay. Sergio is telling us that Excel cannot be a database. So Sergio, I pose to you this question. If I list in my Excel spreadsheet name, address, telephone number, date of birth, and I transpose, because that's a table by itself, and I transpose that information onto a table in a database, why wouldn't that be a database then? And Sergio's comment is very valid in the sense that a database and a Excel or a spreadsheet are very alike in certain behaviors, but the spreadsheet cannot handle the information the same way that you can handle on a database. Now, Both of them can sort data. Both of them can filter data. But the same table that I will have to create in Excel that has 40, 50, 90, 100 columns to manipulate information, I can have in 5 tables in a database, and it's more manageable. It allows me to produce and to collect information and follow this information ladder to create information and wisdom and knowledge faster than the Microsoft Excel. Now, I am not saying, and I have to want to clarify that, I am not saying that the Microsoft Excel cannot help you. It will help you. It's just the key in here coming from the fact that a database allows you to handle data in large quantities, large amounts, in a faster and more efficient way. Now, there is people that will work into a spreadsheet at incredible rates of speed, but never as efficient and faster as you can have on a database. Why? Because the database allows you to link information in such a way that you can extrapolate information faster than the spreadsheet. You can look for information faster on a database than you do on a spreadsheet. This is what you call data mining. When you actually go to the database and look for information, you are data mining a spreadsheet, but it's not going to behave as fast, as efficient, or as good as the information that you got on a database, because the database is going to give you all the corresponding information that you need versus one set of records that appear on a Microsoft Excel or any kind of a spreadsheet, electronic spreadsheet, or paper spreadsheet that you may have. So I'm going to address something that one of you put in here. I have used Excel as a database and used to make labels or envelopes in mass. That is a 100% true statement. The caveat in here is, as I said before, Microsoft Excel handling large amounts of information can never behave as efficient as a database will ever be. It's not efficient enough for you to have 20,000 records and managing them at one time in one single document without getting into errors versus handle them in a database. Why? I say a database is a collection of tables. So if I were to give you a set of labels, a set of data that actually comes in data format, in text format. I give you an example of something that I use all the time, the US Census Bureau. That information comes in text, which means it's written in a word processor, in a notepad format or something like that. And it outlines the information that I'm using in a specific way. It's a way that when I import it into Microsoft Excel, it allows me to read it and understand it in a simple and predetermined way. It allows me to import it into a database the same way and still understand what I'm reading. Now, when I create a table in a database, I specifically designed that table to contain X amount of information. If I want a table to define a specific information for customers, all I'm going to have in that table is the customer name, the customer address, the customer telephone, uh, their location, and the point of contact. And I'm going to assign to that customer an identification number. On a separate table that I'm going to call product, I am going to identify the products that that database is hosting. So by using an ID for the customer that I gave you, and an ID for each individual product that I create into that table of products, I'm now creating a second table to index the information that I'm working with. I still have access to the information on the customer, and I still have access to the products of that customer. If my table for customers has a second customer with the second ID, I can also create on my table of products a second set of products under the second customer ID. So think about what I'm saying. The second customer ID has a series of products. The first customer ID has a series of products. The same product may exist on both customers. For example, hammers. First customer sell hammers, or I buy hammers from him, but it's customer A. Customer B also sell hammers, but his hammers have a flat nose. A hammer is a hammer, but customer B has a different type of hammer from customer A. If I index my database and I tell it, show me a list of hammers, it's going to tell me I have two types of hammers, and it's coming from the table called products. One is called hammer, the other one is called hammer with a flat nose. Each hammer has their individual IDs, and each hammer will have a customer attached to it. When I create something like this in a table, imagine if you have millions of products, of records. You can have 20 million records for products and only 5 customers. Each customer is selling you, or you're selling to this customer X amount. The total amount of product of on the table for products, it accounts for 20 million products, but it accounts for only 5 customers in your whole group of customers. Imagine if you were to do this on a Microsoft Excel. Let's not talking about 20 million custom, 20 million products. Let's talk about 40,000 products, 5 customers. By the time you search that database and index that, by the time you search that spreadsheet and look for the corresponding customer on that spreadsheet by doing filters and by doing sorts and so on and so forth, you could have done everything on the database with one single command. That's why your database, while is much more efficient, is faster. That's why your Microsoft Excel, while you can still use it as a database, is not as efficient, not as common, not as good as handling large amounts of information. On the same hand, if you want to know a chart, you want to make a chart of products sold by company A on the period from December through July, that information probably can be extrapolated from the Microsoft Excel chart table a lot faster than you can do it from the database, even though it can be done from the database too. But that information is probably easier to extrapolate, easier to handle by you, your manager, or your bosses, or whoever, than you do the other one. So both of them have validity. Both of them can be used together, but one is going to be more powerful for the other depending on the capability and the use that they're given. That's why the databases are today more prevalent for large amounts of information. Remember when we talk about the enterprise resource management program that you're going to put on top of your company as an umbrella? What is it guided under? A large database, because it connects everything together in one. That database can create tables by importing data from Microsoft Excel. It's very simple to do. If you have SQL query, which is a way to create tables or to view tables in your database, you can export the database straight to a spreadsheet. Or you don't say the table. You don't export the database, you export a table onto a query, which produces the information in such a way that can be exported directly to a Microsoft Excel document. So they are interrelated, but two very dissimilar functions that eventually the database becomes more and more efficient at handling it. Now, this brings you to this. Each one of these items in a Microsoft Excel document, each one of these items is a cell. Would you agree with me on that? Anne Marie, that's a name, something that you put in one single cell. Last name Cortez or Corres, with a political science pre-law major with a birth date of 2/1/1993. 1, 2, 3, 4 cells on that Excel document. In a database, Anne Marie Cortez, political science pre-law 2/1/1993 is one record. Again, in a spreadsheet, 1, 2, 3, 4 items are 4 different records of that spreadsheet, 4 cells, maybe more if you decide to cover more than one cell per name. Political pre-science, you can expand it to 3 different cells. In any case, 1, 2, 3, 4 different fields make 4 different records on that spreadsheet. In a database, each line in here, each row of the table becomes a record. That's how you begin to see the database now. You're no longer looking at one single individual item. You're looking at a series of items that makes your information. The raw of information is your record. I mentioned to you before that if I create a table called customer and I create a table called product, customer has an ID. For product, I create an ID for the product, but I also create an ID or include the ID for that specific customer according to the product they sell or buy, right? Well, when in essence I'm creating in here, I'm creating a relationship between the two tables. The table customer and the table product now have a relation. Product is related to customer by the ID of the customer. Specific products on the table products relate to the customer table by specific IDs. Each individual product has an ID that is different for every product that we have, but at the same time interrelated. So when you create that, multiple tables are linked together by IDs. That's when we become to understand that there is such a thing as relational databases. We access the tables and we access the information by viewing information based on a relationship that exists between each one of the tables. I only gave an example of two tables, but in this example in here, you got four different tables interrelated to each other. The same thing happened with any other database. Now, a database doesn't have to be relationship, doesn't have to be relational. It's more efficient to work with because you can link different things together and it moves faster. And the most common examples of this is Amazon Aurora, Amazon RDS, Microsoft SQL Server, Oracle Database, and DB2. Those are some of the items that you see in the market, the most common. These are items that you don't buy yourself on a retail format. This is usually something that you have for companies. When you go back and look at that open free software, you can get yourself into SQL databases that you can use yourself for small items. The most common one out there is called MySQL, and it's just as good or powerful to a regular Microsoft SQL database. It's open source. You can run a small business out of it. By it as it may, if your business grows to the point that you need it, you end up buying one of these, leasing it, or getting the licenses for it. That way you can run your operations from it. So it's something that you always going to use because you need to interrelate all that information that enterprise resource management system requires you, and everything is tied together and they're using the database to tie it together. Yes, you can still use a spreadsheet for it. It will be extremely inconvenient and hard to do it. It begin crashing and it will begin getting corrupt really fast. Metadata. Metadata is data about data. When you saw the statement in there, I don't know if any of you went to look for it to investigate what metadata was. This is the simplest definition you're going to find. Data about data. Definition in here. Music files. The most common way to define metadata because it has so much information available on the musician, on the music, on the lyrics, pictures, albums, so on and so forth. And it's being compiled in such a way that you collect information. Metadata is common on this application because of this, but at the same time, it's used a lot in a lot of applications because in today's applications that involve going into cloud systems or into the internet to be accessible by anybody or any user that you want, you end up defining the fields that makes your application part of it. For example, when I create a map of the Corpus Christi Independent School District, I have to define if I want to make that map available to the public. I have to define that map and tell it What is the map about? The map is about boundaries. The map is about populations. The map is about schools. The map is about high schools, middle schools, elementary schools. It's about the district. That means that if anybody out there goes and search for the word Corpus Christi boundaries, Corpus Christi schools, Corpus Christi high schools, they are going to get a reference to metadata that points him towards one of my maps. They may find the information that exists on the website for CCISD that describe the boundaries that exist for the district, but it also going to give him access to the map that I created and I link on the website for third parties to use. So in the background, when I build the map, I have to define metadata for it. What are the items that make the map relevant to whoever is searching? Is data about the data. Who created the file? I created the file. How big it is it copyright? Who can use it? Is it open source? All the sorts of information that you create, that you do, is part of metadata. When you create a database, we mentioned this before, you use the most common way to address that information is called a structured query language, which is basically saying access something, show me something, do something for me. So in here, I'm telling it to do something and do it this way, to define something, to produce or do something and define it as this, where I'm getting it from, and I'm linking it to something else by using an ID that exists on both tables. And then I'm going to tell it to group all the information by the ID. And I'm going to tell it to create an descending order of the sum of the cells and create a description for it. So it's creating a product ID, product name, total quantity, and is listing the information. So this is the software application called a structured query language that you use within a database, some of these databases that I show you, to create something like this. If you use Microsoft Access, Microsoft Access gives you this type of capacity to do and to view SQL. It's not as common because SQL is not something that is simple to use. It takes some learning. It's not difficult, but it takes some learning. It used to be more complicated, but as I said before, when you do programming, now everything is very reflective of the English language, and we have a lot of tools that enable us to see help and how to look for information. So this is a sample of a structured query language, short for SQL, of how to access and query a table or series of tables in a database. Okay, what is big data? Big data is anything that we're using, we having access to, that is extremely large and is no longer stored in a simple repository or hard drive. Now you're looking to have large repositories like at the cloud. Now you're looking at information that is stored and accessed via the cloud. It may be housed in huge hard drives at a specific location, but is virtually produced to be displayed for you and access to you on the cloud. Big data. The biggest example of big data that you can see today is the genome. If you go back and do a search for the database for the genome, you're going to find out that it's so large and so big that you require to have access to the cloud to be able to view that information. Not so much the quick query, but if you want to dig into all the genome, if you want to download the genome, for example, it will give you information that is on terabyte size, which is stored on petabytes or larger than that on a cloud system. As we saw in the first day of class, all these different layers of the way the information breaks down for you, how to store it in bytes, megabytes, gigabytes, terabyte, petabyte, so on and so forth, is because the size is increasing so big that now you need to have all this information working for you. But the easiest way to do it is handling big data, which is usually stored in a cloud. When you work with a database, you work with what is called a database management system, or a DBMS, which is basically saying you have a database on top of a database. It's an application that you use to create databases and manage databases. There are many out there. The most common one that you're gonna have is Microsoft SQL Server, which is a free download, by the way. You can download it. Microsoft gives it to you free because they want to access your computers. They want to access your databases. They want to see and peek onto your information. So when you log into Microsoft SQL Server and download the database for you to use, which you can do, you can download the simple form. It's very powerful. You can still use it. In essence, it's a database management system that enables you as a software to create and manage the databases. Because remember, you may have many tables in one database, but you may have many databases. As your data grows, you build databases. If I want to store all my sales for the month of December, I may keep them in one single database, December sales and November sales, and so on and so forth. Well, what does that mean? That at the end of the year, I will have 12 different databases. At the end of 5 years, I have 60 databases. Well, you may have to reconsider and merge them and have one single database for every 12 databases. So you consolidate, you work with the different enterprise databases so you can actually have information in a more accessible manner to produce better data for you so you can make decisions and gain that competitive advantage. We go back to what we said on the first day of class. The main source of information for you is to gain that competitive advantage. That's what you want. Do you have any questions so far? Any comments? I see a no. Okay. We mentioned this before. Everything that we have together, all that data that we have accumulated, that we've been putting together from a company or from yourselves, is all together coming into one single location. It's a data warehouse. The data warehouse is accessing information for you. It's allowing you to access information. And as you can see here, the Enterprise Resource Program allows you to feed information. Your marketing department is feeding information, HR, sales, data marts, which is actually the market out there providing you information. So it's a central repository or series of central repositories that you're gonna use. Data mining is when you go in here and begin looking at that data. You begin looking for a specific sets of information, looking for trends or something so obscure that somebody wants or somebody needs or your boss or your team needs to develop or need to figure it out depending on the project you're working with that you need to come up with. That's data mining, looking for information on data warehouses, on databases, knowing how to search it, knowing how to access that information. That's what you're doing. Business intelligence and business analytics. Well, business intelligence and business analytics is basically saying, I am collecting information that gives me that edge. It allows me to go up. It allows me to grow that competitive advantage. You notice I keep repeating the same thing. This is a business class application, business management information systems. You are gaining a competitive advantage on your team, on your peers, on your department, on your group, on the companies, your competitors. When you are collecting that information and making decisions on the information you're collecting, you're doing business intelligence. When you're doing the business analytics, you are actually figuring out frequencies. You're actually figuring out trends. You're actually figuring out what's affecting your data collection, what is affecting your product, what is affecting your output, how are you producing, how are you gaining that advantage or not gaining that advantage, what is lacking in here that is stopping you from that intelligence, business intelligence, to get there. That's your business analytics. Now, understanding your business analytics is as much, if not, if not more important than your business intelligence. You have to understand what you're looking at. You have to understand the basic information that you are trying to analyze. What is the trend? What is the data that you're looking for? This goes back to this data mining and this data warehousing. What are you looking for? Because that business intelligence and business analytics are coming from these data warehouses and these data marts. This is what you're mining in order to understand if the decision that you're making is based on solid information. Is the analytics provided to you good analytics by the software or hardware or whatever you're using? Is solid or is it too superfluous? Does it make sense? Or is it so complicated that nobody can understand what you're looking at? Well, that's what is important to get to the point in your business analytics that you understand what you're looking at, what you're collecting, how are you understanding what you're looking for. Your business intelligence, you have to be in tune with this data warehouse and your data mining. What are you looking for? Know what to look for. Knowledge management. This is a very overlooked and very important thing. How are you maintaining the knowledge that your company is accumulating? Does one person have all the knowledge? Does a group of people, a department, control all the knowledge? Do you have a way to access that information? Do you require, or is it required of you that every time a process is put in place and results are obtained, that you document that information. How did you achieve that? Did we achieve that we want? Did we sit down and do an after action review when we finish the project and the project pass or fail? That is important to know because the knowledge management of the company is going to be not on the heads of somebody and not documented anywhere in the company. It's good that it's on people because it's important. People on the floor can make decisions for you and can help you. You may have the knowledge management itself. You may know what everything is. If your peers or your staff do not know how to access that information, do not have access to that information, that knowledge management is actually impeding a lot of the efficiency that you may want to have for your company. So knowledge management is something that is often overlooked, but is extremely important. One of these days, the person that has all the knowledge on shipping and receiving leaves the company. You come back and find out where is such and such. Oh, he left 2 days ago. He resigned. He retired. We don't know where he's at. Oh, he left. He says he's going traveling. Well, how do we do this? He took all the knowledge with him. Option number one, you reach for him and pay him a premium to come back and teach you. Option number two, you start from scratch. Option number three, you have it documented. All you need to go back is reopen it and start the process in place. So remember, your knowledge management is very important for you to have it, to maintain it, to keep it, and to keep it up to date. Let's see. Oh, how interesting. It's now 7:45 and we're at the end of our slides. We covered a lot. There's a lot of information in here. Databases alone, as I said before, will take a whole year worth of classes to do and to enjoy or not to enjoy, depending on any person. But it's just a quick overlay of what a database does for you. Do I have any questions, comments, concerns, issues? What do you want to address?
I don't have anything. Thanks.
Okay. Anybody else? I'm going to stop sharing right now. And I'm going to stop recording.